In this video, we're going to graph piecewise defined functions with the TI-84. Now, hopefully you know what a piecewise defined function is. It is a function whose output values are determined by what number you plug in. So the function expression is broken into multiple pieces depending on which parts of the domain we are inputting. Now, in order to graph a piecewise defined function on the TI-84, you essentially graph those pieces separately. Let's do an example. Let's say we want to graph the function, which is x minus 5 for x values which are less than 2, and which is negative x squared for x values which are greater than or equal to 2. If I want to do that on the TI-84, there's a good way to do it. So let's turn to our TI-84 and do just that. Here we are at our home screen on the TI-84. If I want to graph my function, the first thing I'm going to need to do is make sure that we're in the correct mode. I'm in function mode on my calculator right here. Then I go into the y equals menu. I'm going to have two pieces for my piecewise defined function. And so I'm going to use two y equals. The key thing here is I'm going to take y1 is equal to x minus 5, and then I'm going to take y2 is equal to negative x squared. Most everybody should know how to do that using basic graphing. And now I want to restrict the domain. The way I restrict the domain for each one of these is with the slash or divide key. So I just hit divide, and then in parentheses, I force x to be less than 2. Now, in order to get the less than symbol, you go into the test menu. So you hit second and then test, and then you scroll down to where the less than is, and then we got this. This means my y value is going to be x minus 5 whenever x is less than 2. And on the second one, I'm going to have negative x squared. Again, I'll hit the divide key, and then in parentheses, I'm going to say x has to be greater than or equal to 2. Again, second and then the test takes me to the test menu, greater than or equal to 2. Let me focus real quick on that. That's what it should look like. I'm going to keep these as two different colors, the first one in red, the second one in blue, so that we can see it. And then I will zoom in to the standard zoom to graph that. You can see we have two pieces right here. If you want to see more of that graph, just change the window. So hit window, and then maybe I want to go from a y value of negative 20 to a y value of 10. And that'll show me more of the graph. Couple of interesting things. If I put trace, obviously right now I'm on the first component of my function where we restricted the domain to x values less than 2. I can scroll on that. If I get to an x value that's bigger than 2, then the y value will be undefined. So on that piece. So you won't see it on that piece corresponding. To get to the other piece, to get to the blue piece, just hit the down arrow key or the up arrow key in this case. And that will give you the other component of the piecewise defined function. This one starts at 2 and then goes up. So you can hit 2 and go up. And just like the other one, if we go to the left of 2, our point is not defined on that part. So that's how to graph a basic piecewise defined function with 2 components. Let's do one more example of that. Let's graph this piecewise defined function. Now, this piecewise defined function has 3 components. The output is 8 when x values are less than or equal to -1. The output is x squared when the x values are between -1 and 2. The output is 2x minus 5 when the x values are greater than 2. Let's go ahead and graph that on the calculator. I'm going to push the clear button to clear out my first 2, y1 and y2. Now, in this case, I'm going to do a little bit differently. I'm going to make it so that all of these are the same color. So it looks like they're all a single function. You don't have to do that, but if you want to make them all the same color, you can. We say y1 is 8 for any x values that are less than or equal to 1. Once again, I go to the test menu. Let's zoom out just a little bit for my less than or equal to -1 symbol. This second one will be x squared. I'll come back to that one because that one's going to be a little bit different. And then the third one is the exact same as what we were doing before, 2x minus 5, again, divide symbol, and then in parentheses, x greater than 2. X here greater than 2. Now the middle one is the tricky one. If I just go slash and then type in exactly what we had written down, -1 less than x less than or equal to 2, I would actually get an incorrect graph. In fact, let me just graph it to show you that we do get an incorrect graph. Notice that that middle portion does not have the restrictions that I want it to by typing it in the way I just did. The reason is that this is saying x could be greater than -1 and x could be, or excuse me, we're using any x value greater than -1, and also we can use any x value less than or equal to 2. So this gives me essentially all real numbers, the way the calculator interprets it. What we want is we want all x values which are bigger than -1, and also all x values that are less than or equal to 2. So we need to basically combine 2 restrictions. And the way I do that is again in the test menu. I'll say x is bigger than -1. Doesn't matter if you write -1 is less than x or x greater than -1. And then go into the test menu, scroll over to the logic, and we want the and restriction. So we want x to be bigger than -1, and also our x values need to be less than or equal to 2. So that's what the restriction looks like if we want x to be between -1 and 2. Now when I graph that, I will get the right look of my piecewise defined function. We get 8 as the output value. That's the constant right there. And then we get x squared between -1 and 2. And then we get 2x minus 5 when x is greater than 2. And as always, you can trace when x is less than or equal to -1. We're over here. Once we get above -1, we can hit the down arrow key. And now we're on the portion, which is our quadratic portion. That's up to 2. You can hit 2 and then enter. And then once you get above 2, then we got to push the down arrow key again. And now we're on this piece. So this shows you how to graph a piecewise defined function that has 3 pieces. And I wanted to show you this 3-piecewise defined function because that middle section is a little bit different. So this is how to graph piecewise defined functions. And that therefore, this is the end of the video.